Time has passed, that much is certain, but have you ever wondered why time only seems to pass in one direction? We all know that you can't unring a bell or undo sending that text message. No matter how much we wish we could, we can only go forward. So why don't physics equations that describe our universe work in reverse? And why do we only remember the past and not the future? What is this strange thing called the arrow of time? If you were to look at any physics equation, say E equals mc squared, which describes how mass and energy are interchangeable, or Newton's law of universal gravitation, which describes how every object attracts every other object with a force that depends on their masses and the distance between them, you would see that these equations work perfectly fine if you put in negative values for mass or distance. They don't break down, the math still works. This is true for pretty much any physics equation, but we never observe negative masses, and we never observe things coming together with negative distances. Negative distance doesn't really make sense either, because you can't have 3 apples and 2 bananas be 4 meters away from each other. There has to be a positive number, and it's the same with time. The equation for kinetic energy, for example, is 1/2 times mass times velocity squared. If I were to plug in negative mass, the equation would still work just fine. But we never observe negative masses. You might say that's because we don't have antimatter, but we actually do have antimatter. Scientists have created it in particle accelerators and observed its gravitational pull. It's definitely a thing. So why don't we observe negative masses running around? Or what about plugging in negative time into the equation? Let's take Einstein's famous equation, E equals mc squared, which tells us that mass and energy are equivalent and can be converted into one another. Imagine a ball sitting on a table. It has some mass, so it also has some amount of energy, because that's what the equation tells us. Now imagine breaking the ball into pieces. Each piece still has some mass, so they still have some amount of energy. According to this equation, the total energy of the ball before you break it apart should equal the total energy of the pieces after you break it apart. The total energy is conserved, but what if we plug in negative time? Remember, physics equations generally work just fine if we plug in negative values for mass or distance. So let's take this equation and plug in negative time. If we do that, we get negative energy. But negative energy doesn't really make sense. Energy can't be less than 0. You can't have an anti-ball that when you break it apart creates more balls. It just doesn't happen. Now, you might say, well, you can't travel backwards in time, so you can't test this. But there's a way to test it. There's a way to test the idea that time can't flow backwards. And that is by looking at your brain. Your brain contains billions of neurons, and those neurons contain trillions of synapses. All of these synapses are changing over time. They strengthen and weaken. And those changes in the strength of the synapses are what creates your memories. You have a memory of eating dinner last night because there was a strengthening of a particular set of synapses in your brain. And if you had those same synapses strengthened tomorrow, you would create a memory of that too. You'd have a memory of having dinner tomorrow. So the question is, which synapses are strengthened? The ones corresponding to events that happened in the past, or the ones corresponding to events that will happen in the future? Well, look at this funny thing. Neurons in your brain are continually bombarded with information from the outside world and from within your body. Some of this information is more interesting than others. For example, scientists think that the reason why you remember your first kiss and not the 1000th kiss is because your first kiss meant something special. It was new and exciting, so that event gets encoded in your brain very strongly. Other events in life are also more meaningful. When you graduate from college or get married or have a child, these are big moments in your life. And here's the interesting thing. These big moments don't just affect you, they affect other people too. Like your family and friends probably felt the same way about you graduating from college or getting married. So you shared those experiences with other people. And that sharing made those events even more meaningful. In other words, the meaning of an event depends not just on you, but also on the people you share that experience with. So let's say you share a funny meme with your friend. That's a small event, but you share it with the one person you know will laugh at the same joke as you. And that makes it a bit more meaningful. Now imagine you share that same joke with a stranger. It's still a funny joke, but it's not as funny because you don't share a history with that person, so the joke isn't as meaningful. That's kind of the idea behind why you remember some events and not others. Events become more meaningful when you share them with someone else. Okay, so let's ask again. Do you remember events that are meaningful to you or events that are meaningful to others? Do you remember your past or their future? Well, it turns out that we remember events that are meaningful to us and the people we care about. We remember our past, not their future. Why does our memory flow in this direction? Why does it flow from the past to the future? That's a great question, and the answer is that we don't know. But there's a good reason to believe that it's tied to entropy. You see, in everyday life, entropy wins every time. Hot coffee becomes cold, order becomes disorder. Things tend to wear down, time marches forward. But right at the beginning of the universe, at the Big Bang, entropy was very low. Everything was highly ordered. The entire universe was extremely dense and hot. Entropy increased as the universe expanded, as stars formed, as galaxies formed. So entropy was low in the past, high in the present, and will be very high in the future, the heat death of the universe. Physicists think that there might be a connection between this increase in entropy and the direction of time. They think that maybe time flows in the direction of increasing entropy because there's a lot more ways for things to be disordered than ordered. Maybe that's why we only remember the past and not the future, because it's more likely for entropy to increase. There's a mathematician named Giancarlo Rovelli who says that the reason we only remember the past is that we are observers. We are observers who are born into the universe and who watch it unfold in front of us. He says that if we were to rewind time and run the universe backwards, then we would be like tiny gods. We would be creating universes in which we would be the observers. But we're not. We're not those tiny gods. We're not those observers. We're just part of the universe. So we observe the universe in only one way. And that is why we only remember the past and not the future. So why can't we travel back in time? One possibility is that we can't travel back in time because we can't decrease entropy. You can't unbreak an egg. You can't unspill that glass of milk. You can't unring a bell. You can't undo any of those things. But there's another possibility. Another possibility is that since our memories only go back so far, there are some things that are so unimportant to us that we don't remember them. You can't remember everything you've ever experienced. So maybe those events that are so insignificant to you are your future selves essentially deciding that they aren't worth remembering. So those events get left out of your personal history.